So this section is on the electromotive force and batteries. An electromotive force is actually a voltage, and it's really just an idealized voltage. Up until now, we've been sort of representing it this way, where this is the positive end, this is the positive end, and this is the negative or the ground end. And we normally just call it a voltage, but this is really an idealized voltage, and so we call it an electromotive force. It's just another name for an idealized voltage. So a battery is a little more complicated than this, and so we've modeled it slightly differently. Let me give you an example of a battery. This is a 1.5 volt battery that you used in lab, right? And it's an Energizer battery, and you can use it to, for example, light a light bulb. Here's a light bulb. Whoops, I gotta clip that back on there, right? And so if I want to complete the circuit, and I can just kind of draw it on here, right? I have a wire that comes out of here, right, that goes to my light bulb, and so I'm going to draw it like this, just so you can get a, there's my light bulb, and here's my filament in the light bulb, right, and this is how light bulbs, well, this isn't a great drawing of a light bulb, but that's how a light bulb looks, and then the wire comes out like this and connects over here. And so if you actually look at a light bulb, it's got metal down in this part, and you can't see a lot of it. But if you could look carefully at this bulb, I don't know if I can hold it up there, if you'll be able to see it or not. But pick any light bulb, old-fashioned light bulb, not an LED, and it's got a little spot on the bottom. That's where one wire connects. And any place on the side, that's where the other wire connects, and that forces the electricity to run through the filament. Right? And so, so I take this battery, and here's the wire from the bottom, and I'll connect it to the side. And then I'll connect the top to here, and hopefully you can see, it's a dim light, but hopefully you can see that the light bulb is lighting between my fingers there, maybe. And so we have to complete a circuit. The circuit has to, the electricity has to run, actually runs, well, technically runs from negative to positive. We pretend that the positive charges are running out this way and in this way. And it turns out that batteries don't just give away their charges, don't just pump charges through freely. There's chemistry going on in there, and so there's some internal resistance for the battery. And so we say R is the internal resistance. Of the battery. Still see that on there, and so if you remember Ohm's law says the voltage is the current times the resistance, and so you might have a 12 volt battery here, but if you have 2 ohms of internal resistance and 1 amp of current, then you drop 2 volts across this resistor. And so if somebody was just taking this battery, notice I tried to draw the battery to look like, my battery to look like this battery. It's got a sort of a nib on the top, right? If somebody was to draw current through this battery, the more current you draw, the greater the drop in voltage. And so if I call this point A and this point B, the voltage between A and B is called the terminal voltage. If you put a voltmeter across there, you're measuring the terminal voltage. And if you put the voltmeter there while the current is running, and you know, if this is a car battery is 12 volts. If there's a lot of current being drawn, you might only measure 8 or 10 volts across the terminals of your battery, because if its internal resistance is dropping the voltage, the idealized voltage. As batteries run out of juice, as they say, the internal resistance gets bigger and the voltage drop gets bigger, and eventually your car battery won't start your car, or this battery won't light a light bulb. And so as the battery ages, as the battery loses charge, or loses the ability to supply charge, to pump charge, it's because this internal resistance is increasing. And so the terminal voltage would steadily decline as the battery sort of runs out of juice, as they say. And so I'll do a few examples with this. So in this problem, we say a battery has EMF E. That's the idealized voltage. The question is, what is the terminal voltage? That's the voltage between these 2 points. I'll call this one A, B, right? If its internal resistance is R and it's supplying a current I. And so, so the voltage between these 2 points, VAB, is equal to the EMF minus the voltage across the resistor R. Right? This is 12 volts, and this is a 2-volt drop across this resistor because the current because the resistance is causing a voltage drop. Remember, VR is just the current through a resistor times its resistance. Then this is E minus I times the internal resistance. And you can see that the terminal voltage is reduced by the current times the internal resistance of the battery. If you leave your headlights on, your car uses up its EMF. It uses up its ability to move charge, and then when you turn your engine over, it's got a really high internal resistance. You might draw 100 amps out of your car battery, and if it's even got a slight internal resistance on it, the voltage will be reduced drastically, and you won't be able to start your car. And so, it's not very useful actually to check the voltage on a car battery with a voltmeter, because voltmeters, as we learned in lab, don't draw much current. And so if you go down to like an auto mechanic and ask them to check your battery, they'll put a resistor in there that draws a huge current, like one of those, like a coil from an oven that'll glow red. It'll draw a large current because that's what your car needs to start, and then they'll measure the voltage across your battery terminals. Again, if the current is 0, the internal resistance won't cause any voltage drop because the current is 0. And so you'll measure the EMF of the battery if you just use a voltmeter without drawing any current. And so it's only when you start drawing a big current that you get to test whether or not your battery is good. So in this problem it says, what is the terminal voltage on a 12-volt motorcycle battery that has an internal resistance of 0.6 ohms and supplies 10 amps? Right? And so the first thing we know is that when you talk about just the voltage on a battery, the spec voltage, the voltage is written on the side, they're giving you the EMF. Right? And then they're saying this is the internal resistance of 0.6. The internal resistance again depends on sort of how much energy the battery has left in it, and is supplying 10 amps. That's the current. And so the terminal voltage, which we were calling VAB last time, is the EMF minus the current times the internal resistance, which is 12 volts minus 0.6 ohms times, well, let me put the current first. 10 amps times 0.6 ohms. And that's 12 volts minus 6 volts, which is 6 volts. Now, if 6 volts isn't enough to do the job, like light the light bulb or start the motorcycle or whatever it needs to do, then that won't happen. And that's why you can have a battery that's almost dead, and when you turn it on, try to start your car, it just goes click, click, because the internal resistance in your battery is too high because you've run it out of energy. And so the terminal voltage isn't enough to start the motorcycle. So in this question it says, what is the terminal voltage on a 12-volt battery with an internal resistance of 2 ohms with no current? And so the terminal voltage, we'll keep calling it, is just the EMF minus the current times the internal resistance. Again, the EMF is just the supplied battery voltage minus This time we have no current running. And so this is what I was saying earlier. When you put a voltmeter on something, it draws almost no current. You might as well say it draws zero current. And so if you have a voltmeter in your car and you use it to test your car, even when it's almost dead, you'll still see 12 volts and you'll think my battery's fine. Like I said earlier, it's only when you measure the voltage, when the battery's drawing a big current, like the current it needs to start your car, your motorcycle, that you see the correct voltage, the voltage it supplies. Suppose the current is 5 amps. Right now VAB is 12 volts minus 5 amps times 2 ohms, which is 2 volts. Right? 12 minus 10 is 2. Right? That's probably not going to get the job done.